Welcome everyone to the explainer for Unit 2. Today we're diving straight into the absolute foundational blueprint of all successful software engineering. We're talking about requirements analysis and specification. You know, if you've ever wondered how a super vague idea from a client somehow transforms into a highly structured, multi-million-dollar software system, well, this is exactly where the magic happens.
Think of this as our roadmap for today. We're tracking the whole journey from concept to execution. We'll hit the intro to software requirements, break down functional versus non-functional traits, look at the actual engineering process, feasibility studies, the core SRS document, and then finally wrap up with UML and system modeling. All right, Section 1, Intro to Software Requirements. Let's get right to it, because before you write a single line of code, having absolute clarity on your end goal is totally non-negotiable. So what exactly is a software requirement? Well, it isn't just some simple wish list. It's the process of establishing the actual services the customer needs, alongside the strict rules and constraints under which the system has to operate. It's essentially where the client's grand pie-in-the-sky desires collide with the hard technical boundaries of reality. Now, to keep everyone perfectly on the same page, we actually divide these into two distinct categories. On one side, we've got user requirements. These use plain, natural language, maybe some simple diagrams specifically for the customer. On the other side, system requirements. These serve as a highly detailed, structured, technical contract between the client and the developer. You absolutely need both to survive a project, but remember, they are speaking to very different audiences. Moving on to Section 2, Functional versus Non-Functional Requirements. This is absolutely crucial. Separating the what from the how is a vital mental model here. Master this distinction early on, and you are literally already thinking like a senior software architect. Let's break that down a bit more. Functional requirements. Those are the mandatory operations the software literally must perform. It's the actual services it provides. Non-functional requirements, however, dictate the quality attributes. We're talking performance, security, timing constraints. Basically, functional is usually defined by the user's needs, while non-functional is defined by the technical team to ensure the system actually survives out there in the real world. To anchor this in reality, let's just imagine a library management system. Say a user wants to read an article online. Okay, that is a purely functional requirement. It's a specific, tangible feature. But what if the system demands that the user be authenticated with a password before they can access that article? That right there is a non-functional constraint. It places a strict security boundary on exactly how that functional requirement is delivered. And when you're designing a truly robust system, there are core non-functional metrics you've got to constantly evaluate. You have to ask, is it highly reliable? Is it available 24/7? Is it secure? Is it maintainable when updates are inevitably needed? And is it portable across different environments? Nailing these metrics ensures your system doesn't just function, but actually thrives. Okay, on to Section 3, the requirements engineering process. I want you to treat this next phase kind of like the scientific method for gathering information. It's a highly disciplined framework, not just jotting down notes in a kickoff meeting. Here is what that disciplined framework looks like in practice. Step 1, we start by assessing viability with a feasibility study. Step 2, we elicit the customer's desires and really analyze them. Step 3, we document them formally into a specification. Step 4 is validation, making sure everything is perfectly accurate. And finally, Step 5, we employ continuous management to handle all those inevitable curveballs that development throws at us. I want to highlight Step 4 specifically because it's massive. We overlap validation directly with analysis. See, it's not enough to just write things down. We have to guarantee we're building what the customer genuinely wants. We do this through systematic manual requirements reviews. We build executable prototypes to check functionality early, and we generate test cases to ensure every single requirement is actually testable down the line. Section 4 is all about feasibility studies. Because honestly, before we start gathering requirements or building prototypes, we really have to pause and ask the single most important question in software engineering. Should we even build this thing in the first place? A feasibility study answers that exact question by forcing us to take a hard look at reality. We evaluate schedule feasibility. Are these deadlines even realistic? We look at cultural and political feasibility to gauge the organizational impact. We assess market feasibility to see if consumers will actually accept it. And crucially, resource feasibility. Do we physically have the hardware, the software, the funding, and the trained labor to actually pull this project off?
Which brings us to Section 5, the SRS document. Once feasibility is proven and we get the green light, we produce the ultimate deliverable for Unit 2, the software requirement specification.
Out in the industry, the IEEE standard template is basically the holy grail for an SRS. By meticulously defining the scope, the purpose, and all the constraints right up front, this document acts as an ironclad, binding contract between the customer and the developer. It is your absolute best defense to prevent scope creep before a single line of code is ever written.
But if you take away absolutely nothing else about the SRS, remember this one golden rule. The SRS is absolutely not a design document. No way. Its sole purpose is to formally state what the system will accomplish, completely ignoring how the developers will actually build it. That comes later. And that leads perfectly into Section 6, UML and System Modeling. This is the exciting part, where we finally transition from dense, heavy text documents to visual representations using the unified modeling language. It's where our static requirements start coming to life. Now, you might be wondering, why do we even need UML? Well, think about it. Business stakeholders rarely understand code, right? So UML serves as our universal visual translator. It lets us map out really complex processes, user interactions, and object relationships in a way that non-programmers can instantly grasp. It perfectly visualizes both the static structure and the dynamic behavior of our entire project. To really see this in action, just look at a behavioral state machine diagram mapping out user verification at an ATM. The logic flows flawlessly, step by step. A card is swiped, the system waits for a PIN, the PIN is entered, and finally authentication occurs. It's just an incredibly clear visualization that leaves absolutely zero room for developer misinterpretation. You literally can't get it wrong. So, as we wrap up this explainer masterclass on Unit 2, I want to leave you with a thought to really ponder. If we fail to perfectly capture the functional and non-functional requirements on day one, if our SRS is flawed, or if our feasibility study was rushed, what is the exponential cost of that failure by day 100? Seriously, getting this phase right is literally the difference between a massive software triumph and a catastrophically costly disaster. Thanks so much for learning with me today, and I'll see you in the next explainer.